What up? It's still me. Now, I don't know how many times I've recorded this opening, and hopefully, this video makes it out of day. Who knows? But this one is about parallel lines and a little bit of perpendicular lines and a little bit of bisectors. But mostly parallel lines cut by transversal. Let's just jump right into it. Oh, yeah, let's go. Now that we're going to talk about parallel lines and perpendicular lines, it is important to take note that there are certain relationships, or in case properties, or in this case concepts, that will take place once these things are indicated properly. So this is something that has to be addressed because there are differences on the resulting concepts when you do these things, like when you draw parallel lines, and then when you have perpendicular lines, there are differences in ways of properties that is going to be formed, especially if you have perpendicular lines, they're intersecting. Parallel lines, they do not meet. That, in the first place, is one of their difference. So in this case, let's start with perpendicular lines. It's important to take note that when you have a perpendicular line, I'm so sorry, when you have perpendicular lines, let's say that we have two of them, as indicated in the screen. You have line EF and line GH. So these two lines are intersecting, but at the same time, the difference between these two lines and the regular intersecting lines is that they form right angles. So I would like to reiterate that the reason why the word is that angles instead of just one, because this alone right here is also 90 degrees. Same case here, same case here. Okay, so that's an important detail to take note of. This only takes place when you have two intersecting lines that form right angles. That's what makes perpendicular lines. Okay, so perpendicular lines are things that we see in real life, mostly in rooms, walls, windows. These things are important. Things being in right angle is important for some things to be stable. Speaking of stable, look at your tables, right? The flat top and the feet of it are perpendicular to one another. The reason behind that is for it to stand upright. Okay? So that's how perpendicular lines work. Now, in the case of parallel lines, the difference between the two things, again, as I've mentioned earlier, is that earlier they are intersecting. This time around, for parallel lines, they do not meet or they do not intersect. And the important detail here is that parallel lines should be coplanar. Same case with perpendicular lines. They should be in the same plane. Some important detail that you have to take note of. So, for example, here, line AB is parallel to line CD. I also want to take note that earlier, the symbol that you saw for perpendicular lines is basically like an inverted letter T. While for parallel lines, basically it's parallel segments that are standing upright. So that's how the symbols look like. We see parallel lines a lot. If you notice the image earlier, we see it on railroad tracks because, again, if they're not parallel, the train will not be able to move properly because the wheels or the spaces in the train fits or is basically the same, what do you call this, same way presented, like the wheels are parallel, of course. So if the wheels are parallel, the railroad track should also be parallel with one another so that it could move from one place to another. It's an important detail also. And here in this case, you can notice in this image alone is a cube, and you can notice that we have IJ and MN being parallel. It's not hard to see that, right? IJ and MN, they are on the same plane, the one at top. Next, you have JK and LK. From the name itself, they all share K, or they both share K. And as you can notice in this cube, that forms a right angle right there. JK and LK. Next, we also have PO and NO, perpendicular again because they're sharing this side at O. So they meet at that vertex. I'm so sorry. Vertex, not side. Then IM and JN, they are parallel. IL and PL, they meet at L, that point right there. So they're perpendicular. Then MI and NJ, they are parallel. So it's because the given is a cube. Next. Now, one of the things that is important to take note of, especially with parallel lines, is what happens when a transversal cuts through. Now, A transversal is already a line. That's why it's not called as a transversal line. It's just called a transversal. I just want to reiterate that. It's because, again, it's already a line. So it's the yellow one right here, or line C. It passes through both parallel lines. And this is the important detail. That's why in our learning target, there is a certain detail there that was noted properly, that we are to identify the properties of parallel lines when a transversal cuts through it. So as you can notice in this image, with one transversal, there will be 8 angles formed from it. And these angles are the important details that we have to take note of. One of them is what we call as the corresponding angle postulate. So we have here in this image angle 1 and angle 5. Disclaimer to everybody. The numbering here will be different, depending on the given examples. But the reason why we're indicating it as 1, 2, 3, 4, 5, 6, 7, 8, as indicated earlier, so that it will be easy to follow through. But the important detail here is not the numbering, but the position. So corresponding angle, from the name itself, corresponding. So you can imagine this as if you have the two lines separated. So let's just draw them properly first. So let's just say that we can draw this as two separate lines instead of, the parallel one that we have here. So I'll draw the line separately. Uh-huh. I'll draw the transversal as color blue. I just realized I should have stick with the, using yellow instead, but here we are anyway. So as you can notice here, we can say that this is line A, this is line B, this is still line C. If you look at the image alone, the way that we separated this, you can notice without using a protractor, you can already say that this angle formed right here is the same as the angle formed right here, the black one. Okay, that's angle 1 and angle 5. So that means that when you have a pair of lines that are parallel cut by a transversal, you will have four pairs of congruent angles that follows the concept of corresponding angles. So first you have angle 1 and angle 5, followed by the angle formed here and the angle formed here. So we can say that that is angle 1 and sorry, not angle 1 but angle 2. So we say it's angle 2 is congruent to angle 6. We can also say this angle formed right here and the angle formed right here. Let's say that's 7, I think. Angle 7 is congruent to, wait, no. You can say it's angle 3 is congruent to angle 7. And lastly, we can have the angle formed right here, you know. The one that I'm drawing is curves, so the amount of curves implies what's the partner of it. So this will be discussed better or further once we go to triangles. So in this case, we can also say that angle 4 is congruent to angle 8. So again, the important detail here is that it's good that you learn how to somewhat illustrate the image in different ways so that it will be easy for you to identify. This is an important skill, especially when we go to triangles, where you can redraw the triangles on your own so that you can understand it better. So for corresponding ones, basically the angles correspond to one another. We have 1, 5, 2, 6, 3, 7, and then 4 and 8. Next, we also have what we call as alternate interior angles. We don't have to dwell much on this, but we can go and dissect the name itself. So the first thing here is that it's interior. So this means or implies that it's inside the parallel lines. Hence, as you can notice already, we're just focusing on four angles, the ones in 3, 4, 5, and 6, because they are inside the two parallel lines, A and B. Now, the word alternate, to put this into perspective, you may think of the crisscross or the butterfly, where 3 and 6 are partners, and then 4 and 5 are partners. The relationship of that these pairs have is what we call as alternate interiors, and they are congruent. Hence, we have 3 being congruent to 6, 4 being congruent to 5. The word alternate again thus means that not on the same side, and at the same time not adjacent. Okay, So I think that's the best way to put it in mathematical terms, because 3 and 5 are not alternate because they are on the left side, both of them. At the same time, 3 and 4, they're not alternate because they are next to each other. The word there is adjacent. That's why it's 3 and 6 that we consider as alternate. Hope that is clear now. So again, the word alternate means that they're not on the same side, and at the same time they are not adjacent. And among the four of them, it's only true for 3 and 6 for the pairing. Same case for 4 and 5. So that's it. My English grammar is not grammaring. Please forgive me for that. Let's go with the next one. So the next one is the same concept, but the difference now comes in with the word exterior. So the exterior implies outside the parallel lines. And again, by alternate, not adjacent, not on the same side. So 1 and 8, 2 and 7. They are congruent. Again, this is the symbol that we use for congruence. It's different from the equal sign. There's like an N, is it a tilde? I forgot what it's called. I forgot already. But a student of mine mentioned it to me. Anyway, let's go to the next one. Next one is what we call as vertical angles. Vertical angles basically doesn't exist just for, transversal parallel lines. It exists for all intersecting lines. Hence, in the definition, if two lines intersect, okay, the vertical angles formed will always be congruent. So in this example, you have 1 and 4. They're vertical to one another. 2 and 3. Same time, you have 6 and 7. And lastly, 5 and 8. The important detail here for vertical angles is that they are in front of each other. They are not next to each other. So basically here, the term that I want you to remember is that when they're vertical angles, they are non-adjacent. That's why 1 and 3 are not vertical angles. 1 and 2 are not vertical angles. It's 1 and 4. Okay? Because they should be non-adjacent, meaning they should not be next to each other. Now, for the first four relationships that we have mentioned, all of them are congruent. The next one will be a tad bit different. This is what we call as a linear pair. A linear pair again exists when you have intersecting lines. And in this case, an important detail here is that they are supplementary. That's why you should have a certain measurement to remember. So this pair should be equal to 180 degrees, the measurement of them. Now, I want you to take note of the difference between the way we write it in symbols. If you take note of this, there's now the letter M. The letter M means measurement. And when you are talking about measurements, you no longer use congruence. Instead, you use the equal sign. Okay? So remember this one. If you're using the letter M or measurement, you don't use congruence. You use equal. So this one takes place when two angles are adjacent. 1 and 2 are next to each other. They form a linear pair. Hence, the measurement of angle 1 plus the measurement of angle 2 is equal to 180. Here's the thing that I want you to understand. The reason why the letter M is important, because if you have angle 1 plus angle 2 equal to 180, this is mathematically incorrect. The reason behind this is because we are not adding angles. We are adding their measurements. That's why it's important to have the letter M in there. Okay? So in this case, we can actually identify not just 4, but additional 4 more pairings. So we have 1 plus angle 1 and angle 2 forming a linear pair, angle 3 and angle 4, angle 5 and 6, 7 and 8. But also we can have 1 and 3, 2 and 4, 5 and 7, 6 and 8. The reason behind this is simple. It's because they are on the same line. Earlier, it was separated, line A, line B. This time around, the ones that I highlighted with green are the ones formed in the line C, which is the transversal. They form a linear pair still. Okay, let's go to the next one. We don't need this anymore. Okay, this one we have to deal with for a while. So let's start talking about the two-column proof. The two-column proof is basically something that we use in logic and reasoning. This one is one of the kinds of proving that you will have to deal with in the future also. But in this particular case, we are going to focus on two columns. There are diagrams, there are, paragraph versions of this, but here we're going to practice the two column proof, where basically you put the statements on the left and the reasons on the right. So it's much better understood when you have examples. So let's say that we have here the alternate interior angles theorem. So given that A is parallel to B, prove that angle 3 is congruent to angle 6. Now, one of the things that I want everybody to understand in the first place, or first things first probably, is that there will always be a given like this, or the problem will always be like this. It states here that the given is A parallel to B, or A is parallel to B. And as you can take note or see, that's how we start. A is parallel to B. Hence, the answer there should be given. Again, this should be the given because it's given. It's common sense. Okay? Now, for the transversal. For the proving, I'm so sorry, I'm not here anymore. For the proving one, that's how we end. But we're not gonna write the reason as proved. No, 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 that's wrong. We're not gonna write that. So that's the one thing that we're gonna figure out together. So first we look at the statement. It says here that angle 2 is congruent to angle 3. We know that's by vertical angles because we know that vertical angles are congruent. And then next, what's the relationship of angle 2 and angle 6? That's what we have to figure out. They're now corresponding angles. So corresponding angles are congruent also. And then, in this case, we can say that by transitive property, they are congruent. If I'm not mistaken, I think the better one to be used here is substitution. I'll recheck myself on that one, but that's basically how a two-column proof works. We always start with a given and end with what we're trying to prove. Okay? So let's have, I think, two more examples. Let's have a long one. Oh, this one I like. Okay. I would like to explain this one. So we have here this given: if a transversal intersects two parallel lines, then consecutive exterior angles are supplementary. So we have the given again, given A parallel to B and C is a transversal that intersects A and B. So that's automatically our given. Again, my dear children, we start with the given all the time. Now, if you look at this, angle 1 and angle 2 are deemed to be congruent. And we know that they are corresponding angles. So we go with corresponding angles postulate. That's our answer there. Corresponding angles postulate. Now, in this case, you might be wondering, sir, what do you mean by definition of congruent angles? Here's what I would like to dive in deep for a second. When we say the word definition, from congruence, it will be changed into measurement. So what we will put here is basically measurement of angle 1 is equal to the measurement of angle 2. Okay? So again, just to clarify this, when you're given with a congruence and you're trying to identify the definition of it, basically it's implying the measurements being equal. And this also works vice versa. So if you're given with the measurements being equal, by definition of congruent angles, two angles that were given are also congruent. Again, that's what we mean by definition. When you have a given, when it's given in symbols. Now, the difference between that and the next one, number 4, is definition of a linear pair. You're not given anything there that is, you know, in line with linear pairs already. The first thing is that you know that a linear pair implies that there should be two angles that form it, and that will be this one. Okay, so we say that angle 2 and angle 3 form a linear pair, and this is where the other one comes in. By linear pair postulate, we know that angle 2, there's a correction here. This should be end. So angle 2 and angle 3 are supplementary angles. That's by linear pair postulate. So this is what I want to also dive in deep now. What I want you to take note of on number 6 is that, yeah, shout out to Peter. He showed up there. Anyway, so the number 6 one here is by definition of supplementary angles. Why is it definition by supplementary angles? You might ask. Wait, let me write it up first. So the reason why this is definition of supplementary angles is because, excuse me, we start with angle 2 and angle 3, identifying that they are linear pair, and then that they're supplementary. Hence, if you add their measurements, it will be equal to 180. That's the definition of supplementary angles. And lastly, our final answer will be by substitution to lead us to our answer. Why is it by substitution property? You might ask that. If you take note, number 6, you have measurement of angle 2 plus the measurement of angle 3 is equal to 180. And we establish in numbers 2 and 3 that angle 1 is congruent to angle 2. That's why from measurement of angle 2, it became measurement of angle 1. That's how the substitution property worked in here. So we did prove that they are supplementary, the consecutive exterior angles. So that's how proving works. Okay, let's have one last proving for parallel lines. Where's that one? Here we go. So now we'll try to prove if two lines or two parallel lines are cut by transversal, then the alternate exterior angles are congruent. So as you can remember, we proved theorems, and since the alternate exterior angles is a theorem, we have to prove it somehow. So again, we will always start with the given. Given always. Given. Now, you might be confused, sir, why are there two things that we need to prove? Basically, we're gonna prove two things in this case. That's why it's a tad bit long. But we start here one by one. So we always do this in succession. So we have angle 1 and angle 4. So you can take note, they are vertical angles. So let's write vertical angles theorem. Next, it said that we should find a pair of angles that are corresponding to one another. We only have two options: angle 2 congruent to angle 3 or angle 4 congruent to angle 8. And that's the one that is corresponding. So that's what we write. Angle 4 is congruent to angle 8. And this is how transitive works. Since angle 1 is congruent to angle 4 and angle 4 is congruent to angle 8, therefore, angle 1 and angle 8 are also congruent. This is by transitive. So that's how it works. That's why I wanted to correct myself earlier. This is how the transitive property works. Basically, if you're confused with that, transitive says, for example, you have A is equal to B and B is equal to C, then A is equal to C. That's how the transitive property works. Next, let's have number 5. It says vertical angles. We only have one answer here left. Angle 2 being congruent to angle 3. So let's write that down. Next. So angle 3 and angle 7 are also corresponding angles. So let's write that down here. Corresponding angles postulate. Next, angle 2 and angle 7 by transitive property also. This is one thing that I would like to explain. Yes, in these examples, it's in the basic mode. There are choices. But here's one thing that you have to remember. When you have a long proof, sometimes you have to repeat some things. And it's normal. You don't have to overthink it. As long as it's correct, there's no problem with repeating. Okay? Just like in life, you don't have to worry about things much if you're repeating things. As long as it's correct, it's worth repeating, if that makes sense. So this is how the two-column proof works and with proving. Now let's take a short pause and I want to discuss this. I don't have a slide for it. Please forgive me because you might see this in the future. So let's say that we have, let's say an angle. Yeah, let me draw an angle correctly. Yeah, let's have an angle like that. Yeah, what a perfect angle, right? So let's have this here, and let's have this one here. It doesn't look perfect, but let me explain. So let's say here that we have points here. So we have A, B, C. So as you can notice, there is an angle formed at B, but then you have this certain red line, and I want to call it as BD. So BD here is a segment that serves as a bisector. Okay? So the word bisector can be related to different concepts: perpendicular bisector, or basically an angle bisector. From the name itself, bi and then sect, this thing divides an angle into two equal parts. So for example, this one that we drew here is actually accurate. It was indicated earlier that this one is 90 degrees because, again, we use the angle properly here, the ruler, if I'm not mistaken. So this is 90 degrees. Since the segment BD is a bisector, this implies that the angle formed in ABD is equal to 45 degrees. And the measurement of, let's say, CBD is also 45 degrees. Again, why are they equal? It's because BD is an angle bisector. Okay? I just want to mention that. So for perpendicular bisectors, basically it's the one that I showed in the beginning where two lines intersect and they're perpendicular to each other. So it bisects it to both both to 90. That's why it's 90, 90, 90, 90. The lines there bisect one another also. That's an important detail for you guys to remember. Anyway, that's it for parallel lines cut by transversal with some bits of proving. That ends our video about parallel lines, perpendicular lines, and bisectors. And always remember that, you know, you know, yeah, that's my phone. Always remember that. Anyway, peace out. Always remember, good morning, good afternoon, good evening, and good night. Always be respectful. Peace out. It fell. Bye bye bye.